Hello, in this video, we're going to learn about how to write the half-cell and overall cell reactions in electrochemistry. Let's say you are given a galvanic cell, like what you have in here. For the anode's half-cell, we have zinc solid electrode, and we have zinc sulfate 1.0 molar electrolyte in the anode's half-cell. And on the other hand, we have the cathode half-cell consisting of copper solid and also 1.0 molar copper sulfate solution electrolytes. So how are we going to write the half-cell's reactions and the overall cell reaction for the given galvanic cell in here? So to do that, first of all, you need to think about writing the anode, cathode, and overall at the bottom of the anodes and cathode. And think about the mnemonic that we have looked at in the previous video when we learned about how to draw galvanic cell. We have the oil rig, which is going to be the mnemonic for oxidation is losing electrons, reduction is gaining electrons, and we have the red cat mnemonic simply to tell you that reduction happens at cathode. So you're going to use this mnemonic to help you out to fill in the anode half cell and the cathode half cell, and finally writing the overall cell reaction. Let's go back to the galvanic cell that we have seen just now. Again, on the anode half cell, on the left-hand side of your screen, we have zinc solid as the electrode, and we have zinc 2 plus aqueous ion that comes from the 1.0 molar zinc sulfate solution as the electrolytes. So how are you going to write that as the half cell for anode? So we know that the anode is going to be anode, red cat, anode, cathode, red cat, red cat. Therefore, it's going to be cathode. Okay, so reduction, if you look at your oil rig, RIG, reduction is gaining of electrons. So the cathode over here is gaining electron and anode is losing electron. Okay, so how are you going to write the half cell for anodes and cathodes? Anodes, we have zinc. Okay, so anode is losing of electrons. So you're going to have zinc solid, and because for anodes, when you lose electron, the electrons will be part of the products. Okay, so you are going to be losing electrons, and zinc will be converted into zinc 2 plus aqueous right there. And how much electron you're going to have? That over there, you'll be having plus 2 moles of electrons, because you have 2 plus right there. Okay, remember, anode is losing of electrons because oil rig oxidation is losing electron, and oxidation will happen at the anode. Why? Because based on the mnemonic red cat, reduction at cathode. Okay, so for the one in cathode, you're going to have here the cathode, the Cu2 plus aqueous, okay, Cu2 plus ion in the aqueous phase will start to receive the electrons, and they will be reduced to become copper solid at the cathode. So we have copper 2 plus aqueous Over here you have 2 plus, so you're going to plus 2 electrons, and you will reduce that to become copper solid. Okay, so when you look at the equation now, you have 2 mole of electrons on the reactant side for the cathode, okay, because cathodes is gaining of electrons. And then you have 2 moles of electrons on the anode side, okay. On the product side of the anodes, they are on the opposite side. Therefore, we can cancel that, and we can combine both of this together. So when you combine that, you'll get zinc solid plus Cu2 plus aqueous, okay, and you'll have zinc 2 plus aqueous plus copper solid. So this is how you're going to write the overall cell reaction. So in terms of marking, so what will you be getting? So by writing the correct half cell for anode, you'll get 1 mark, cathode 1 mark, and the correct overall cell reaction, you're going to get another 1 mark. Let's have a look at another question. So over here, instead of giving you the galvanic cell, the diagram of the galvanic cell, you have in the form of phrase, okay? So you have to write the half cells and the overall cell reactions for silver solids at cathode and iron solids at the anode. So how are you going to do this? Okay, first of all, look at this piece of information over here. Okay, so you're going to have the silver, okay, Ag solids at the cathode. So that is going to be the electrode, and you have iron solids at the anode. Remember, cathodes is the gaining of electron process, and anodes is the losing of electron process. So the iron over here will be losing electrons. Okay, so how are you going to write it? We're going to start with the anode first. Okay, so for the anode, you'll have iron solid, okay, and the stable oxidation number for iron would be Fe2 plus aqueous. So that you need to remember. What is the stable oxidation number for the iron? And of course, to balance that out, you need to add 2 moles of electron. And for the silver part, the Ag solid over here, you'll get Ag plus aqueous. So this is the most stable oxidation number for silver. Okay, you have Ag plus aqueous. And then to balance that out, you need to add 1 mole of electron. Then you'll get silver solid. And before you want to combine these 2 half cells together to write the overall cell reaction, you need to look at the electron. Can we cancel that out? No, because that one is 2 mole of electron. We want to make sure that there will be no electron in the overall cell reaction. So you have to make sure all of the electrons to be canceled out. Over here you have 1 mole, 2 moles, and how you're gonna solve that problem, you're gonna take this whole thing over here. Okay, you're gonna take this whole thing over here, then you're gonna times 2, then you'll get Ag plus aqueous plus electron Ag solid, you have 2 mole, 2 mole, and 2 mole. And now we can proceed by canceling out that electron, and we can combine to form the overall cell reaction. You have iron solid, and you have 2 Ag plus aqueous, and you'll have Fe2 plus aqueous plus 2 mole of silver solid. So this is the overall cell. Okay, so that is the overall cell reaction. Again, by writing the correct half cell for anode, you have 1 mark. For cathode, you have 1 mark. And for writing the overall cell reaction, you will have another 1 mark. Okay, so if you want to draw this in terms of galvanic cell, you can have it drawn in that format.